So someone asked me to revise angle of elevation and angle of depression. So let's revise everything you need to know before the test on this concept. So let's say, for example, you are standing here. So what is angle of elevation? So you're looking at something tall. Let's say it can be a house, Eiffel Tower, Statue of Liberty, anything. So this is the line of sight, right? So angle of elevation always is always an angle between this line of sight and the horizon or horizontal line. So here we go. That will be the angle of elevation, right? Now, how we work with angles of elevation, we complete this into a right triangle. So we draw a vertical line. So for example, we know height of Eiffel Tower or height of the building. So that forms a right triangle because horizontal lines and vertical lines are perpendicular. So now we have a triangle. So if we know this angle and one of the sides of this triangle, we can find any other missing side, or if we have two sides, we can always find the angle. So again, it's angle. Let me just highlight here between the line of sight and the horizon. Now, let me give you a definition of angle of depression, and then we're going to talk about some examples on this. So, for example, angle of depression, it's right the opposite. You are somewhere elevated, and you're looking at something down, right? So you're looking, I don't know, you're standing somewhere on the top of the building, and you're looking at somebody down there. And again, the definition is exactly the same. It's the angle between the line of sight and the horizon. But now we are going to complete this into another triangle. So I'm going to draw another horizontal line right here, because usually we deal like with something standing. We can maybe know the height. So I'm going to complete this to a triangle. And instead of working with this angle of depression, so again, that's according to definition, it's the angle between the horizontal line and the line of sight. I'm going to work on this. I'm going to work with this angle. And I'm claiming that these two angles are congruent. Can you explain why? So remember, this is a horizontal line, and this is a horizontal line. Two horizontal lines are parallel to each other, and therefore we have one pair of alternate interior angles, and they must be congruent, or the measures must be exactly the same. So instead of working with this picture, again, we're gonna just copy this measure right here and work with triangle. Again, we bring it down to right triangle, and all what you need. So basically it's same as working with trigonometric ratios. Since we have right triangles, we're going to have some angles, some sides, and we're going to use sine, cosine, tangent, and inverse sine, inverse cosine, inverse tangent. But the main trick in this topic is just to understand the word problem and translate it into a right picture. That's the only problem here. Once you have a good picture, that's it. Like you just need to use right trigonometric ratio, and you're good to go. So let's look at a few examples. I'm just going to make up some numbers and just explain some of the things you might see. So for example, you're standing looking at something up, right? And let's say we know the height of this, I don't know, building. Again, these numbers might be not accurate, not realistic, but I'm just making up some numbers, right? So you're looking at some building, maybe 12 feet. Now, here we have an angle, 42 angles. And let's say we want to know the distance from you to the base of this building. So let's call it X. So there are some words you might use like as keywords. So for example, distance to the base, that will be this horizontal leg of your right triangle. So usually most of the time, most of the pictures will have this angle of elevation as this bottom angle, but not always. So you always have to, again, make sure you have the right picture. That's the key in this topic. So distance to the base. This is one indicator you're dealing with this leg. Horizontal distance. How far apart? So this is our indicators most of the time, but again, it does not always work. So you always have to double check. This isn't most of the time the indicator you're talking about this horizontal line or horizontal leg. Now, what are some keywords maybe for this leg? So let's say vertical distance, height, right? Tall. All these are talking about the vertical leg. And if you have here, so distance from you, let's say to an object, that could be one of the things. So let's say we have this setup. You're looking at something tall, 12 feet tall, you know the angle of elevation. Again, we use definition, angle between the line of sight, you're looking at the top, right? So you're looking straight up, and here's the horizon. It's always good to make pictures, maybe like throw some grass, like to understand more what's going on. Now, let's see what we have here. Let me just take a highlighter and use, okay. Now we need to decide what trigonometric ratio we're going to use. And let's see what we have in terms of this angle. So in terms of this angle, this is the opposite leg, and this is the adjacent leg. That means we're going to use tangent, right? Opposite over adjacent leg. So we're going to say tangent of 42 degrees equals to opposite over adjacent. So from here, the x goes up, tangent goes down. Or you can always rewrite it as proportion. If you cannot see how the things move up and down when we change the sides, solve it for x, right? So it's 12 times 1 divided by tangent of 42. So 12 divided by tangent of 42. Now you just put it in the calculator, and I got 13.3. And whatever units you have, don't forget to put units. So if you have feet, you put feet. Okay, now, and from this picture, again, we can find, once we have one side of the triangle and the angle, we can find any of the other legs or hypotenuse. So let's say this one is the hypotenuse, we call it y. Can we find the y from this picture using what is given initially? Let's erase x. Yes, we can. So again, we're going to check what is given in terms of this angle. Let me just erase this. Yeah, here we go. So we have opposite leg and the hypotenuse. So that stands for sine. Remember, SOHCAHTOA, right? Opposite to adjacent, we use tangent. Opposite to hypotenuse, we're going to use sine. So sine of 42 is opposite leg to hypotenuse. So again, you can complete it to a proportion. And from here you have y, and just put everything in your calculator. Y equals to 17.9. And by the way, the hypotenuse should be the longer side, so that makes sense. Okay, now let's try something else. Hold on. Okay, now let's make another picture. So we're still working on angle of elevation. Now I want to show you one type of a problem. Sometimes it's confusing. So let's say you're standing somewhere elevated. So let's say you're on the second floor or whatever, right? And here's the horizon. We have grass here, right? And now you're looking at something, let's say up here, higher than you. So you're looking maybe at another building that is next to you and that is more elevated than you. So here again, we're gonna draw a vertical line. So we're gonna use this vertical line. This is the height. So let's say we need to know the height of this building. So let's call it x. Okay, now, and using the definition of angle of elevation, again, it's the angle between the line of sight and the horizontal line. So as you can see, the x is bigger than what we have here. So this is your angle. Let's say it's given as 38 degrees. Now what to do here? Right? We still want to deal with triangles. So once we, actually the initial picture was not a triangle, right? It was like trapezoid. But now we completed this. We have a triangle and we have something else. So we can work on this triangle. And let's say, you know, the distance between the two buildings. Now, we cannot find the x, but what can we find using this triangle? We can find, let's call this y. We can find one of the legs of this triangle. And if we know the y, and we know this, that this is 5 basically, right? Because this is a rectangle. We have 2 vertical lines and 2 horizontal lines. So once we know the y, we can find the entire height of the building. So again, look for keywords. Let's say the distance between the buildings. So that should be put right here. This is 10. And again, since it's a rectangle, that will be also 10. Again, angle of elevation, we go by definition. Now, let's see. Looking at this triangle, again, I want to highlight what we have. So 10 is, so for this angle, 10 is the adjacent leg and y is the opposite leg. So let me write here. So, ka, toa. So if we have 2 legs, opposite adjacent leg, we're gonna go with tangent. So tangent of 38 equals to opposite leg over adjacent leg. So again, if you want to complete it to a proportion, you can solve it for y. So basically y times 1 divided by, equals 2. So y times 1 equals 2 tangent of 38 times 10. Now, when you put this in a calculator, in your calculator, the calculator will open the parentheses for you here. So before you continue writing 10, don't forget to close parentheses because otherwise the calculator will multiply 10 with 38 and then find the tangent, right? So that's how we multiply. And that should be, I got 7.8. Okay, now since we need the height, the entire height of the building, so x will be y plus 5 or x equals to, so 7.8 plus 5 equals to 12.8. And again, feet, meters, whatever unit you have. And let me give you one more picture for the angle of elevation, something really important. So let's say, again, you're standing, let's say you're standing here, you're looking at something. Maybe it's a ladder leaning on the building, right? This is the base of the building, again, horizontal distance. And let's say it's given as 8. You're right here, so that's you. That's the ground. And we need to find the angle given that, let's say the ladder is 12 feet. And again, don't forget, we always get the right angle triangles because we have horizontal and vertical legs that form right angles. Those are perpendicular. Now, how to find this angle? Remember, we have something called inverse trigonometric ratios. So again, we always start with the angle. It's all related to the angle. For this angle, what do we have? We have the adjacent leg and we have the hypotenuse, right? So based on that, we're going to use cosine, adjacent leg over hypotenuse. So cosine, the angle always goes inside the trigonometric ratios. So, and we go by definition. Again, look, math, if you just go by definition, most of the time you'll get it. So cosine is adjacent over hypotenuse. Now, of course, we cannot just divide by cosine here or do anything else. To get x from this equation, we need to use something called inverse cosine. So on your calculator, it's probably going to be like shift cosine. So it's sometimes called arc cosine. So double check. And here inside, we're going to put 8/12. So this function basically answers the following question. Cosine of what angle equals to 8/12? And that will be 48.2. That's what I got. Okay, let's do a couple of examples on angle of depression, but again, they're pretty much the same. So let's say you're sitting somewhere up, right? You may be on the helicopter flying, looking at something down. So according to definition, that's the angle of depression because you're looking down, so the angle goes from horizontal line down. But we don't want to deal with this angle. We want to deal with angle that is included in the triangle. We're going to use this angle again. These are alternate interior angles. Lines are parallel. And let's say this angle is 24. Again, this is a right angle. And let's say you are 15 feet above. Again, I'm just making up numbers. If it doesn't make sense, then just we are practicing. Now, we need to know the distance, the horizontal distance, for example, to this object. Let's call it x. And that's it. Once you have the correct picture, you're all set pretty much. So for this angle, what is given? We have adjacent leg, we have opposite leg. Remember, that comes that is for tangent. We use adjacent leg and opposite leg. So tangent of 24. So angle always goes inside. Sine, cosine, and tangent is opposite over adjacent. So here we go. You can set it as a proportion. And x will be 15 divided by tangent of 24. And by the way, let me just quickly give you a shortcut. Whenever you have a proportion, whenever you cross this equal sign, right, you want to go to the other side, whatever is down will go up. So x went up. Tangent was up, it's going to go down in the denominator. And that's it. 15, if we want to move it the other way, that also is going to go into denominator. But we want to have x in the numerator. Okay, so let's continue and just put these numbers into the calculator. I got 33.7. So again, depending what you have, let's say if you need to know the distance, not horizontal distance, but let's say you want to put a rope between you and the object, right? How long is the rope? How long is the ladder? Whatever, right? So at this point, if we don't want to use x and we have the same setup like this on the picture, again, we start from the angle. What is given in this triangle in terms of this angle? It's the opposite leg, and this is the hypotenuse. That means, so opposite to hypotenuse, we're going to use sine, right? And let's write it down. Again, we start with definition. Sine of 24 is opposite over hypotenuse. Y equals 2, 15 over sine of 24. And that will give you 36.9. So here we go. And let me give you a couple of more examples. Again, if you are somewhere elevated, you're looking down, but that object is already also elevated. It's not on the ground. So let's say we know this distance is, I'm not sure, 30, let's say. Okay, now, here's the ground. We have grass here. Right, let's continue, complete the picture. So we are always using the vertical distance as well. So let's say we need to know how far you are from the ground. So let's call it x. Again, we cannot work with this shape. It's a trapezoid. We want to complete it to a triangle. So we actually going to use the definition of angle of depression. We need to complete the horizontal line, right? So this is Here we go. So that will be the angle. And hold on. And let's say the angle is 32. Let's say it's 32. And let's say you have a rope again or anything. Let's say this is 89. So distance from here to here, let me highlight it, is 89. Now, what can you find using information here? So this is a right triangle. In order to find x, x is much bigger than this leg, right? It's taller, but we can actually find this leg, and this will be, again, this will be 30, because down here we have a rectangle. We have two vertical lines, two horizontal lines. They're all parallel to each other, all congruent. Okay, so if you can find this leg, we can find x. So that's the plan. So again, in terms of this angle, we have the opposite leg and we have the hypotenuse. So that's sine. Sine of 32 is opposite to hypotenuse, right? Use a proportion. So y equals 2 sine of 32. Again, your calculator will open bracket parentheses, close it, and then multiply by 89. So y equals to 47.2. To find the total height, we're just going to add 30 to this number, and that will be 77.2. I'm not writing units, but you should add the units all the time. And let me give you a final example. So let's say if you have you're sitting here, again, you're looking down at something. Maybe you're at the roof, this is a ladder, you're looking down, this is your angle, but of course, we're not gonna use this angle, we're gonna use the angle that is congruent to this one, but inside a triangle. So this is your angle of depression, and that is congruent to the same angle. Now, and we need to find that angle, given, let's say that ladder is 19, and the height is 14. We always start with the angle. What is given in terms of this angle? We have opposite leg, and we have the hypotenuse. That means we have to use sine. Sine of this angle is opposite to hypotenuse. So again, we play around what is given and use accordingly different trigonometric ratios. In order to find x, we're going to use inverse sine of 14 over 19. So that function gives us what angle gives you sine with this value. And after that, you should get 47 and 5.5 degrees. So that's all. Again, read keywords and just start with good picture. Good luck.